This is lesson 10-4, solving radical equations. To start, radical equations are any equation that has a variable in the radicand. And when we have these equations, now they can be linear equations or first degree equations, or they can be quadratic equations, second degree equations. But anything where it has a radical and the variable is underneath the radical, making it a radicand, is considered a radical equation. Extraneous solutions are any solutions to a radical equation that we obtain but do not work in the original equation. And we have to do mandatory checks with these radical equations to find out if solutions are going to be extraneous. To solve a radical equation, the first thing you want to do is isolate the radical term on one side of the equation. Now, if you have an equation where radicals are on both sides of the equations, just continue right on and we'll deal with it in a different way. You then want to square each side to get rid of the radical and then solve the equation just like you would any other first degree or second degree equation as you have learned in the past. And then you must check for extraneous solutions. That is a requirement here. In the past, teachers have told you that checks can be optional. Checks cannot be optional with radical equations. You must check your work to make sure that solutions are not extraneous. Let's take a look at this guided example that we have here. So we have solving radical x plus 2 and then plus 7 equal to 16. So the first thing we want to do is isolate the radical. And to do that, I'm going to subtract 7 from both sides here. And that isolates my radical on one side. It gives me radical x plus 2 equal to 9. At this point, then, I'm going to square both sides to get rid of that radical term. And now, the nice part about this is that when you square a radical, you can just basically take away the radical sign. So I'm left with x plus 2 equal to, and then 9 squared is 81. And so then I will subtract 2 from both sides, and I get x equal to 79. Now I do have to check, so I'm going to go off to the side here, and I have 79 plus 2 underneath the radical, and then plus 7 equal to 16. I'm going to combine the terms underneath the radical first. That gives me radical 81 plus 7 equal to 16. And then, so that now is 9 plus 7 equal to 16. The square root of 81 is 9. And that gives me 16 equal to 16. So it checks out. So 79 is a viable solution, and I do not have to reject that solution. Here's some examples for you to try. Pause the video at this point to give yourself a chance to try them on your own. So for the left side, to isolate the radical, we're going to add 5 to both sides. And that gives me radical x equal to 17. And now I'm going to square both sides. And I get x equal to 289. To check that, we'll go with radical 289 minus 5 equal to 12. Radical 289 is 17 minus 5 equal to 12. And 12 is equal to 12. So that does check out, meaning that 289 is a viable solution for this radical equation. On the right side, we are going to square both sides first. Now they both have a radical, and both radicals are isolated, so we are going to square them both. So we end up with 5x minus 11 equals x plus 5. And The x is the smaller one, so I'll take care of that one first and bring it over. So I have 4x minus 11 equals 5. We'll add 11 to both sides to give me 4x equal to 16. And we divide by 4 to get x equal to 4. In checking that, we have 5 times 4 minus 11 equal to 4 plus 5. 5 times 4 is 20 minus 11 equal to radical 9. And 20 minus 11 is 9. And I don't need to really go any further at this point. That does check out, but you could also say that 3 is equal to 3 and check it out as well. Here's a couple more examples for you to try. Pause the video at this point to give yourself a chance to try them on your own. So we have the radical isolated, so we're going to square both sides in our left side example. We're going to square both sides. Now I have x squared equals x plus 12. And since I have x squared, this has now automatically become a quadratic equation. So I'm going to subtract x from both sides and subtract 12. And that will get me into standard form of a quadratic equation. At this point, I can factor using the basic trinomial factoring shortcut, where I can put x in front here and x in front here. And then factors of negative 12 that add up to negative 1 are going to be negative 4 and positive 3. At this point, we're going to invoke our split set solve, the zero product property. And when we add 4 to both sides here, x equals 4. When we subtract 3 from both sides here, x equals negative 3. So now it's our responsibility to then check both of our solutions. So we'll start with the 4. So 4 is equal to the square root of 4 plus 12. And 4 is equal to radical 16, which is true. 4 is equal to 4. So 4 does work. That is a viable solution. And then when we try negative 3, so negative 3 is equal to the square root of negative 3 plus 12. And negative 3 is equal to the square root of 9. But the square root of 9 is equal to positive 3. Negative 3 is not equal to positive 3. So therefore, we're going to cross this one out and we reject it as an extraneous solution. And if a question were to ask for why you are rejecting that answer, you would say it's an extraneous solution. For the right side example, I'm going to subtract 8 from both sides first. And that gives me radical 3x equal to 4. I'm then going to square both sides. And so I get 3x equal to 16. And we divide by 3. And x is equal to 16 thirds. It's okay to keep it as 16 thirds. You could keep it as 5.3 repeating or 5 1/3. Totally your choice. I prefer to keep mine in the form of an improper fraction. And so now I'm going to check my answer here. So we have radical of 3 times 16 over 3 plus 8 equal to 12. When I multiply 3 times 16 over 3, I get 16. And radical 16 is 4. And 4 plus 8 is equal to 12. So 16 thirds does become a viable answer for that radical equation. If you're having any issues in any portion of this lesson, please make sure you are emailing me or consulting me in class.